Welcome back to part 2 of Module 7, Lesson 2, where we're going to continue our study in writing and solving two-step equations that involve the distributive property. They've given us a new one here for example 3, very similar to the other examples we've worked, only now they want us to play with a fraction. Not a big deal. I tell you guys all the time, fractions are your friends. So, first thing you want to do is decide how you want to work this one. You can work it using the division approach they did, or you could work it using the distributive property, which is probably how I would choose to do this one. Let's see what they did. They chose to divide it. And in dividing, instead of dividing both sides by 2/3, they multiplied both sides by the reciprocal, which is 3/2. Now, once again, I keep telling you guys, don't do what the textbook does here. Don't stick it on the front. Stick it directly after the number you're doing. So I would have done 2/3 times 3/2 here, and then I would have done 10 times 3/2 there. But either way, things are going to simplify out. The 3/2 and the 2/3, they divide each other out, leaving n plus 6. And then on the right-hand side, they took that 10 and made it into an improper fraction, and that's going to allow them to simplify it, where 2 is going to go into 2 once, 2 is going to go into 10 5 times, 3 times 5 is 15, 1 times 1 is 1, and 15 over 1, that's where this 15 here came from. From there, we're going to undo addition and subtraction by subtracting 6 on both sides, here and here. Check that. It's going to check, and of course, that's going to leave me with n is equal to 15 minus 6, going to be a 9er, and the answer checks. That works great. Probably not what I would have chosen if I was doing it. I would have chosen to use the distributive property approach, but there's nothing wrong with the option that they chose there. And now it's going to be your turn once again. Go ahead and solve this problem, work it out, and if I was you, I would do what they did on this one. I'd go ahead and divide both sides by the negative 1 over 9, also known as multiplying both sides by the reciprocal. Did you get it right? Let's see how I'm going to end up working this problem. I'm going to start off by multiplying both sides by the reciprocal, so I have 1 over 9 times a negative 9 over 1. From there, in parentheses, we keep the v plus 5 equals the 6, and then I'm going to do times that 9 over 1 again, which is still going to be negative. When I do this, these zeroed each other or divided each other out. They're gone, leaving me with v plus 5 on the left-hand side. On the right-hand side, if you take a look, 9 over 1, that's just 9. Negative 9 over 1, it's just negative 9. So I'm just going to take and focus on the 6 times 9 is going to be 54. Positive times a negative is a negative. Now if you wanted, you could put the 6 over a 1, and when you did that, you'd get the negative 54 over 1, which, guess what? Negative 54 over 1, it's still negative 54, which is what I have here. Now I'm going to undo addition and subtraction by subtracting my 5 from both sides. Oops, put that one in the wrong spot. Let's take and put it a little more over there. These 5 zero each other out, leaving v is equal to, signs are the same, find the sum with a sign in front of your larger number going in front of your answer. Jump back over to our answer sheet. I had negative 59, I think, is the answer I came up with, and it checks. Easy math. You can do this stuff, people. Now, just like last time, you guys can solve these using either the arithmetic or the algebraic approach, or at least in theory you can. I'm not going to let y'all use the arithmetic approach in middle school, but we're going to show you what it would have looked like if you'd still been a little elementary kid. 3 friends went to a band party at a local farm. Each student spent the same amount of money and a total of $21 altogether. Each student bought a hot dog for $5. If they each also bought a hayride ticket, how much did each hayride ticket cost? Well, you could take and solve it using either, like we said, the arithmetic or the algebraic approach. In the arithmetic approach, you would take and divide the total amount spent by 3. So the 21 divided by 3, that means that each student spent $7 apiece. From there, you would take and say, well, we know how much the hot dog costs. That's $5 for a hot dog? That is highway robbery. Evil. So, we'll come back down here. We're going to do that $7 that we had left over here, subtract the $5 for the wiener, and that meant the hayride itself, it only cost $2. Now, this approach works great if you're in elementary school, but you're not in elementary school anymore, so that means you need to be doing big kid math. In our big kid math, they said to create the equation 3 times the sum of the cost of the hayride and the hot dog together. So they did 3 times the hayride and 3 times the hot dog, or they chose to divide both sides by 3. That works too. Divide by 3 here and here. That left you with x plus 5 was equal to 21 divided by 3 was 7. Then they undid the addition and subtraction by subtracting 5 on both sides, and that left you with x is equal to 2 for your answer. Now, once again, the arithmetic approach, great if you're a little kid. You're not a little kid anymore. You have to be doing the big kid algebraic approach if you want credit for it. And that brings us to an inquiry question which wants to know, how can you use a bar diagram to help solve problems involving two-step equations containing parentheses? Luckily for us, I'm pretty sure they're going to give us another video to help answer that question. And maybe not. It says Annika purchased 3 identical bracelets and a pair of earrings for $25.49. The earrings cost $11.99. How can you use a bar diagram to find the cost of just one bracelet? It says draw the bar diagram and then be prepared to explain it. So let's take a look at that. We've got it broken down into some sections here. You can see that I've highlighted already that the 3 bracelets and the earrings together all cost $25.49. Meanwhile, the earrings themselves, they were $11.99. So we're going to take and make our whole bar. The total bar, of course, included 3 bracelets and 1 set of earrings. We know that the entire bar cost $25.49. We also know that the earrings cost $11.99. So to solve this problem using the bar diagram, you take and subtract the $11.99 from the $25.49, and then the value you got left, you would divide that amongst the 3 bracelets. And that is exactly what I would put in the question of how I would do it. To write that as an equation, you can see you have 3 times the number of bracelets, that's right here, plus $11.99 for the earrings, that's right here. And what does it equal? It equals the entire cost of everything. Now, some real-world situations can be modeled by a two-step equation in the form of P times the sum of x and q is equal to r. Consider the following problem. Mr. Vargas takes his class of 24 students ice skating. Each student pays an entrance fee to enter the rink and a $4.75 fee to rent skates. The total cost for the students to enter the rink and rent skates is $234. What is the ice skating rink's entrance fee? Well, let's find out. First thing we're going to do is describe the model using mathematics. So we're going to say that 24, the number of students, times the total cost for each student to enter the rink, and the total cost for each student is going to be $234. But remember that you had a variable for the fee to get in the rink and the renting of the ice skates themselves. So these two things combined, they're the blue. They match up to the total cost for each student. You have to have both parts. Put it as an algebraic equation. You would say that 24 students times the sum of the fee and the skates is going to equal to 234. Now, once again, they're not going to make us solve that problem, but they do want us to solve this one. Mackenzie drives the same distance to and from school each day. She also drives 1 3/4 miles round trip each day to go to the library. During a 5-day school week, Mackenzie drives a total of 50 miles. So you can see her little route that she has mapped out there. Not that it really matters to us at all. What does matter to us is how are we going to write that information as an equation. Well, in words, if you look at it, you can see that it's 5 days, so we have to do this 5 times. And every day, what does she do? Well, she travels a total distance every day, and 5 times each day's distance, that's going to equal 50 miles total. But how do we find out the total distance she drives each day? Well, we know that they decided to let D represent the distance traveled to and from school. So each day's distance is the distance to and from school plus the 1 3/4 mile it takes her to go to the library. If you add those two numbers together, you get the total distance. If you looked at it on a bar diagram, you can see you've got 5 days broken up into the distance to school and the distance to the library combined. And each of those 5 days combined, well, that's going to equal the total of 50 miles that she's driven. And with that, we have what we need to create our equation. 5 days, that's where this 5 comes from, times what's in each day, the distance driven to school and the distance to the library. That's what's in blue right here. And what's the total equal to? It equals the 50 miles you see in the entire bar diagram. Now, unless the homework tells you to, I'm not making you make the bar diagram. I am, however, expecting you to be able to write the equations. And now it comes time for us to actually solve that problem. And you can see they've used a division approach again. They took their original equation, they took this 5 that was being multiplied by the sum of the distance traveled each day, and they divided it on both sides, here and here. The 5's on the left divided out, leaving 1 3/4 is equal to 50 divided by 5. Well, that's going to become 10. Next, they subtracted 1 3/4 from both sides, with it zeroing out on the left, leaving D, and on the right, 10 minus 1 3/4. Well, that's going to leave me with 8 1/4. It doesn't appear that my 8 took hold, so let's stick that 8 in there again. Accept and check, and our answer checks. So the total distance that she travels to and from school, that's going to be 8 1/4 miles. The total distance she travels each day, that's going to be 10 miles total. Really not that hard to work. Now this is where I'm going to end part 2 of this video. Come back for part 3, and you're going to get an opportunity to solve one of these problems on your own, and then we're going to take a look at one more set of examples before we shut it down.